Good afternoon, good morning and good evening wherever you are in the globe. Thanks for investing your time and attention to attend this inaugural Green IT Awareness webcast. I hope you are enjoying the content and seeing and hearing other people's experiences from around the world. As IT makes up about 2% of the world's carbon, moving out of it's important to put it in the context of data centers and what they contribute, but also we're now seeing more and more in the home with media centers and large hard drive capacities, mobile phones with more memory and processing power than a mainframe of the 1970s. Computing is becoming ubiquitous, and this is why we need to plan now about how we use it and how we manage it in the future. The converse is true though. If we took away IT and the processes it supports and went back to inefficient manual processes, our carbon footprint would explode beyond any predicted level. Today I will introduce myself and my company, NAB. I will talk about IT carbon footprint and discuss the IT ecosystems and the implications of thinking of IT from the whole supply chain. We'll also discuss NAB's journey towards trigeneration and why we chose it, the process of trigeneration and how we make our own electricity, the importance of planning in the data center and the method of planning. We'll zoom into the data center as part of the ecosystem and see some examples of how energy can be used more efficiently as well. My background is over 20 years in IT with National Australia Bank and across several different areas of technology, including operations, automation, services management. My current role is data center strategy and sustainable technology. I'm a certified data center designer and an ITIL expert. The National Australia Bank, locally known as NAB, is the fourth largest bank in Australia. We are a financial services organisation of 38,000 people and more than 1,800 branches and service centres. Our fleet is made up of 4,800 ATMs servicing our 10 million customers worldwide. We provide services, products and advice through our major Australian franchise and businesses also in the United Kingdom, New Zealand, United States and Asia. We are motivated to make a positive and sustainable impact in the lives of our customers and communities. At the heart of our group is a belief in the potential of our customers and communities as well as others. This belief is defined in always trying to do the right thing to help our customers and communities and to ensure they realise their potential. This belief led us to start a journey in 2007 to be carbon neutral by 2010. We will shortly be achieving this goal, and we have done so through three main methods: reduction, migration to green power, and carbon offsets. In the Carbon Disclosure Project, we scored in the 98th percentile, making us the best performing Australian bank in that review. Our properties teams have also been involved with neighbours in the scoring of our office building performance since its inception, and indeed they have even been involved in neighbours' data centre pilots. This background shows the care we take and the measure we take of tracking our carbon footprints. But this journey is not a destination, it is always continuing and the bar always increases. We looked at technology's carbon impact in the finance sector, and this review by Gartner research shows that more than any other sector, IT has a large impact in financial services. The green column shows the percentage of carbon of the organisation used in finance services. This shows that in finance, where we mainly sell services, IT is a big player of everyone's carbon footprint. Closer to home, we measured our own impact. This was technology's call to arms, so to speak, because it indicated that our 2 enterprise data centres were a third of the organisation's carbon footprint. With much more IT equipment distributed across the fleet, we realised that we were the single largest factor in our carbon footprint. Out of the 2 data centres, out of the 800 buildings that we are in, these 2 made up 33% of our carbon footprint. So this meant that we had to take large strides to catch up, as these were the only buildings that were increasing their carbon footprint, and we needed to turn that around. So technology, working with our partners in properties teams, started making changes to our data centres. The expanded IT ecosystem is just a simple way to show how different areas affect the whole IT supply chain. When we look at IT and the changes we want to make in efficiency, we need to look at the impact right back from supply in the data center and the equipment it houses, right through to the customer. If you adopt this approach, it allows you to balance gains in one area and its impact across the whole entire scope. Let's look at the supply side. If you investigate electricity's carbon footprint, you will find it varies from the region you're in and the power source it comes from. Hydropower has a very different carbon footprint to brown coal, and even makes a difference on how far you are away from the source and how much transmission loss is caused till it gets to you. This is partly why we now see large organisations like Google building data centres very close to power sources that makes their power sources cleaner. By having less loss in transmission, they are effectively lowering their carbon footprint. We looked at grid supply in our area, and it was mainly brown coal, and hundreds of kilometres from the source was our data centre. So this made us look at the viability of other sources of energy. Making electricity on site reduces our transmission losses to near zero. The carbon footprint per kilowatt of our electricity reduces many-fold. Trigeneration gives us both electricity and cooling load that further reduces our need for electricity. Because the data centres need large amounts of electricity and cooling, which are both outputs of trigeneration, this creates a symbiotic relationship to trigeneration and the data centre. We will look further at the data centre later, but now let me explain the trigeneration process. The process of trigeneration in our data centre is depicted here. It is sometimes called CHP, cooling, heating and power, by the 3 phases that it goes through. In our data centre, it is efficient because of the output of chilled water as well as electricity, and it is fundamentally using and reusing the energy multiple times, each conversion folding the energy back for reuse. I'll explain the flow of energy in our data centre. A trigen gets its name from the fact that the energy is reused 3 times or in 3 steps. The first step is gas to electricity. The gas comes in from the mains and into a generator and is burned. which is seen as the green box on this diagram, and the electricity is feeding our IT load for about 50% of the whole load. Step 2, the heat that comes from the exhaust is turned into cold water. This exhaust comes out at over 300 degrees and is farmed into a device called an absorption chiller that converts a refrigerant liquid into its gas state with the heat. Once in gas state, it is very cold, and it can be used to chill the water that feeds our air conditioning units and keeps our IT load cool. The third step, the last step, the remaining heat into hot water. So after the heat load is cool enough to use in heat exchangers, we make hot water for washing or even in heating office spaces if needed. These are the three phases of trigeneration and how we use it in our data center. This slide shows the arrival of the trigeneration generator and motor, as well as the absorption chiller. It's important to note the size of these equipment and the large installation that it was. This was not an overnight planning. This took about 2 years from inception to turning it on. So you need to do some planning and be ready for it. Trigen has many advantages in that. Firstly, we are saving 20,000 tonnes of carbon a year, and that will keep on going year after year. When we decided on trigeneration, there's a few things that affected this decision. The fact that DCs need both power and cooling is one reason. The cooling requirement is proportional to the electricity load needed, so Trigen scales to provide both the power load and the cooling load. Server CPUs are getting more powerful, but also more hotter, so the heat concentration in our data centers is increasing. At our site, chilled water is the cooling method and will be appropriate for the next few years. We may even see the need in the future for chilled water to get closer to the server. Already we're starting to see in-row and in-rack cooling solutions, and in the future we may even see water cooling the CPUs directly. Making an IT master plan. This comes from the DC, the Data Center Pulse group in the US. This is a framework that allows you to understand the relationships in your data center ecosystem. So you can measure the impacts and understand and coordinate its flow-on effects to other areas. This ensures that gains you make in one area won't be lost somewhere else. The framework allows you to plan better and ensure you make the right management choices in your data center. As you can see, it's broken into themes, stacks, and sustainability, and everything has a metric. The metrics move out from individual layer metrics where you might measure a server out to top level data center things where you might measure the power load into a room or a section and then the data center. And along the way you capture the carbon counts, and move out. Eventually data centers would like to see certification processes that actually give consistent metrics around how their performance is going, the way PUE is often used in data centers today. So under these themes of software, platform, physical, real estate and environment, you can see that there are stacks that correlate to these and ways of modifying or changing these in the virtualization, in server layers, storage layers and network. The physical distribution layers, the spatial layout of your data centers, and the mechanical infrastructure that powers your data center is the last part of the stack. All of these have different effects, and all of these have solutions that can be used. Servers, we're seeing consolidation and virtualization becoming common. Also in storage, we're seeing virtualization of storage, that is removing large chunks of storage by deduplication and other techniques, or just even selectively hierarching the correct storage with the correct power ratio for the performance you want. This allows archives to use slower and less powerful disks. In the network, we are seeing changes as well, with fewer and fewer pipes at higher capacity going into the back of the servers. Now with 10 gig Ethernet becoming more common, and fibre channel over Ethernet, where conversation now moves to make consolidation of servers easier because the bandwidth into and out of the server is not constrained anymore. Plus, around the corner in the next year or two, we'll see 40 gig fibre and 100 gig fibre bandwidths appear in the data center. The physical distribution of the servers and the spatial relationships comes down to items such as how you lay your data center out and basic design. This can improve efficiency enormously when laid out correctly in hot and cold aisles, separating your hot air from your cold air streams, and other things like that. In the mechanical areas, technology such as what we've talked about in trigeneration is a new thing, and we are the first data center in Australia to do this. But I believe this will become commonplace in the future because of its close fit and relationship to data centers. We will see more and more of this type of technology roll out. And there are other solutions in the mechanical areas as well, with more efficient chillers and airside economizers becoming more prevalent in both cooling towers in offices and cooling towers in data centers. So these are all aspects where we can start making improvement, and by looking at this simple set of tables, you can start seeing how one will affect the other and understand their relationship. You shouldn't concentrate in just one area. As we have shown today, the ability to deliver Trigen into a data center was really important to the real estate components, but we must also do work in the server, storage and network to be successful. So Trigen gave us a cleaner power source, but this is only part of the process, as we discussed. We now need to ensure that our equipment uses that precious resource called electricity effectively. So now we're going to take some time to look into how the choices of architecture and the equipment you buy affect the data center, and how small changes can make large differences. There are many ways to improve your data center, and there is no wrong or right answers, but it is possible that if you look at the framework we just suggested, that if you find one area is outside your influence or not possible in your organization, it gives you other options of which you can take in those subject and theme areas. So when you create your data center master plan, look for opportunities elsewhere and balance these out. Here are some that we've had success with. If you look at your mechanical plan, a rule of thumb would be that take the age of the equipment, and about 0.5% per year is the type of efficiency gain you would expect by swapping that equipment out. So let's say you replace a 20-year-old computer room air conditioning unit, you can probably expect it to be at least 10% more efficient than the old model. This guide helps you to find things that help build your business cases and areas to look into. Once you look into these design issues, and look at the details of placing them out, you'll probably find that this was quite modest, and you may well exceed this with even higher percentages gains. But often the rule of thumb is true: the older the equipment, the more gain you can make. Not just the efficiency of the equipment should be looked at. It's often also the capacity of the output. So while you may be able to swap the equipment out with a lower power ratio, you may be able to do more work as well. Understand when a new servers are provided with transformers that do the electricity conversion at 92% efficiency is replacing an older server at 80% efficiency. Your model uses 12% less power to do the same work. And as a bonus, it produces less heat, which means your cooling requirement is lower in your data center as well. Consolidating data centers can look expensive, but large data centers, while they're expensive to run, they can afford a higher quality of very efficient equipment. So moving equipment like servers from smaller computer rooms to an efficient data center may reduce your annual running costs by between 20 and 50% depending on the site. Virtual desktops have many advantages, but they are now becoming practical as a mechanism to lower the footprint of your buildings, and the centralisation of the IT load with the proper IT cooling may well mean that you can make this a carbon reduction scheme as well. It is worth noting that a desktop can produce about the same heat in the office space as the person who sits in front of it. Even more if it's not powered down at night. But the basics still stand in the data center of hot and cold aisles. Better heat separation means better efficiency. Physical separation in the form of containment units or chimney racks, and even sealing the floor tiles so that there is no leakage of air into the wrong places and being wasted and recycled. Some of these things seem quite simple in their concept, but they can return large efficiency. Building on previous successes is about taking one wing, such as what we have with Trigen, and growing how to use that more effectively in other areas. This slide is just one example of how you can improve, starting with basic items and moving up the stack for the next step and the step after that. This shows people your planning and the long-term impacts on your data sets. If planned correctly and in the correct order, depending on your situation, then the cost savings can be reinvested and actually help fund the next stage. This could be done in a different order, and some may be able to do simultaneously. But the maturity that comes from each learning and each stage will allow you to move on and tackle the next, even if many of these things seem daunting at the start. Be careful not to take on too much, because you may be setting yourself up for failure. And also, perhaps you won't be able to tell which one gave you the best returns. The data center ecosystem for servers. This is a power comparison. The powertrain in the server is a very important story of the ecosystem, as well as showing here a side-by-side comparison of what server consolidation and virtualization can achieve. Here we can see how we can reduce power by up to 90% if you tune your ecosystem by using power management inside blade capacity on the hardware. There is also smart software available on the hardware, like DRS, which is dynamic resource scheduling, that can allow you to move loads into certain parts or cores or even certain blades on the hardware. This frees up unused components and you can power them down. This further compounds the benefit of virtualization and consolidation, reducing your power load enormously. Less servers, of course, means less network connections needed. most network connections need two connections for redundancy. So the reduction of servers means less switches, less routers, and less power needed upstream to actually make your IT load work. Eventually, less hardware in your data centers means the cooling units slow down or go into standby for longer periods, and you make even more returns from the compounding energy savings you make. So if we look at the servers and look at the e-waste comparison of what consolidation and virtualization can do, if we stack up the servers next to a blade server, we can see that half a metre of blade server would be the equivalent of 5.5 metres nearly of servers. So all of a sudden we've gone from one box, from one truckload of servers to one box. This makes a huge difference at the end of your life span of your equipment. And remember, by the time your next generation equipment goes out the door and you'll finish with it, there well may be regulations about how you have to dispose of it and what you have to do with it. And this may be your cost burden, it may be the vendors, depending on where you are in the world. But these things need to be factored in when you're planning and buying new architecture. So today we've talked about a lot of things, and this is only just an introduction to most of these subjects. So I will leave you with some references that may be useful to find more information about how to tune your IT ecosystem and how to improve in different areas. Some of these places, such as Allan's Berkeley Labs in the US, do a huge amount of research into data centers and the efficiency of IT equipment. And there's a number of people that can help you learn more about these subject areas. So in summary, trigeneration helped clean up our energy carbon footprint and made our data center enormously better, but the whole ecosystem of the data center is under scrutiny and needs to drive other reductions so that IT can maintain or even reduce its impact on the earth. And our customer requirements, as our IT services grow, we can minimise the impact for the future. So, as I said earlier, this is not a destination, it is a journey, and with times coming and going, we will find new technologies that will come along and make us more efficient. But we must always be on the lookout, and we must continue to plan for future growth. Thanks for your time today. I hope you're enjoying the whole week, and hope you can make time to attend other sessions as well. Thank you.